Good. Hello. Welcome to the final installment of our pre-lab videos. So today we'll be talking about how to do dynamic mechanical analysis for our polymer samples. We have a goal of 3 different tests today. The instrument that we'll be using is a discovery rheometer, and the rheometer is optimized for shear, but it has a load cell that will allow us to do tension, and the interface is pretty much exactly the same as you would see on a classic DMA, something like the GHR or the Q800 from TA Instruments. So the first thing we want to do is make sure that the air is on. So the instrument assumes frictionless bearings, and the frictionlessness comes from the air. So over here we do have the air on. It is open. You can see it open here. If this was not, you want to open this. This is the shut position. But this is open. Sorry, it's hard to lift and do it at the same time. So, right, open that way. We have our frictionless surface, so now let's go ahead and load our geometries. So we'll be using a tension clamp here. So our thin film will go into our 2 clamps between them, and we will measure or we will apply a strain and measure the stress. So first things first, put it in the bottom. And it just clicks in with a magnet, nice and secure there. And put that in there. Put in the top geometry. There is a knob up here, and so I'm turning the knob now. And just finger tight, no need to over tighten. And you can see now it rotates because this is a rheometer. It's meant to do shear. So we need to lock that in place since we're just going to be measuring strain in the y direction. And so the way I like to do this, I bring the head down. Not too fast, not too close. But you really want to make sure there's no fake shear. Okay. When I get it close enough that I can just kind of have my finger back there, so you can see it's really nice and lined up. There's a little lock right here, and I press the lock button. And now, no longer free to rotate. Just back that off a little bit. Behind the scenes, it's not moving on here. It should be. Okay. We're ready to move over to the computer anyway, so we'll table that for later when we come back and load in our polymer sample. So here, no gloves on the computer. Just like, when we were over in the lab, you don't want to touch your cell phone with your gloves. You don't want to touch our computers with the gloves either. This is the infamous Trio software, so we double click on it. And since we're actually going to be running the instrument, I'm going to click to open. We are. All right, so first things first, we are going to want to make sure that the instrument knows which geometry we have in here. So we're going to go into geometries, and we're going to select our correct geometry, which I'm not seeing in here. So we're going to go into Toggle Smart Swap. The instrument is smart enough that it should know which instrument this is, or which geometry this is. And let's see. it is, film fixture. Great. So what we want to do now is to zero the gap. So we'll get to know the length of our sample just from the instrument. We'll also measure it using calipers, but we can set the gap to 0, and then the instrument will precisely measure for us. And so that is this little icon here, 0 gap. And you want to make sure you're pretty close because it's going to lower fairly slowly. So I am going to, on here, lower the head just a tiny bit. And then I'm going to hit 0 gap. And you can see the instrument is very slowly bringing the 2 heads down. You can also see that it unlocked it, so we're going to have to get it locked back into space. And the gap zeroing is in progress. The head 0 is completed. Do we want to raise to the loading gap? I never do, because it moves pretty slowly. Also, while it's right here, this is a good time to get it all lined up so that you don't have any extraneous shear stresses when you're actually just trying to apply tension. So we click no. So I back it off just a teensy bit. And now we want to lock it in. So once it's lined up, get locked, and now it is. So now we raise. And now we're ready to consider our polymer geometry. So, using calipers, we're going to measure our polymer sample. You need a length, width, and thickness. And